We have created the subnet, we have created a private route table, and we've associated the private route table to the private subnet. We have launched a NAT instance within the public subnet, and we have configured the security group of the NAT instance that it would allow traffic from the subnet, HTTP traffic. So one of the things I mentioned that we need to do on the NAT instance, which is a standard configuration of EC2, but something that we have to specifically change. To go to, so you select the NAT instance, go to actions, networking, change source and destination check. So by default, it gets enabled. In this case, because if it's a NAT instance, we have to disable it. So this is a key step to be done. Otherwise, the NAT instance won't work. So if we do not disable, for example, so as the default property of the EC2 instance is it normally picks up a traffic and check whether they are the source or the destination. If they are neither of them, they drop it. That's the property. This is to avoid the EC2 to be compromised as a forwarder or to act like an intermediary for the traffic to be passed through them from a security perspective and also performance perspective. We have pretty much everything we need. The last bit we need is the actual instance within the private subnet. So we need a private instance. Let's launch an instance. So here we are going to launch a private instance. So that's an instance within the private subnet. So that's here. So we are launching the private instance. So I'm just going to choose the standard one. Did I choose the, yeah, standard one? Yeah. Right. We will launch it in the private VPC and the private subnet. So which means it will get launched here. So you can see here, assign public IP, use subnet setting, disable by default. Because we have not allowed this subnet to be able to automatically assign public IP addresses within any resources that are created within the subnet. So that's why this status is disabled. When we launched the NAT instance, you might have noticed it was enabled automatically because we were launching in this subnet. So that's the, if you like, the key difference between the public and the private subnet and how you can find out whether a subnet is a private or not within AWS. It's a quick way to find out. So that's the private subnet we need to choose. Nothing else to do. Storage, fine. Tags, let's add. Private instance. Okay. Can anybody tell me what we have to do here? So we are launching the private instance here. The two tasks we discussed were, one, to be able to access this private instance from the public instance. Second, to access internet from this private instance. To be able to do those two things, so for the intended purposes, we are going to do an SSH from here to here, right? So we need to be able to allow both siders to be able to access the SSH. So I'm just going to quickly add likewise, I'm opening this internally as well. Let's review and launch. Launch. Let's create a separate key pair. because it is a private instance within the private subnet, it's always a good practice to create a separate key pair. So we have a key pair that we normally use to connect to our public subnets to here, right? So the instances that are launched here. However, it's a good practice to have separate key pairs created and maintained for the private instances. Okay. Okay. So from an infrastructure perspective, let's see what are the things we have. So we have the public subnet, we have a public instance, we have a private subnet, we have a private instance, we have a private route table, we have a NAT instance within the public subnet, and we have internet connectivity for the public subnet through the IG. So we have all the required resources in place. Let's see. So the